Let's discuss the features that are included with Red Hat Enterprise Linux 6. We'll unlock the screen as usual in LCBT. This is an instance of Enterprise version 5 that we will attempt to upgrade. And it's running 2.6.18 kernel. The new version also runs 2.6, different minor release. That's cat etc Red Hat release. This will confirm the current version, and it's 5.5. So this is the latest incarnation of the major version 5 that we're running on this system. Now, Red Hat does not suggest that you upgrade from one major version to another, such as 5 to 6, 4 to 6, 3 to 6. However, it is possible for many installations to perform an upgrade without much of a worry to be concerned about. But sometimes, with respect to more complex configurations involving RAID, perhaps Intel BIOS RAIDs or other types of special RAID drivers, you may experience glitches. iSCSI is one that comes to mind that could cause trouble when trying to upgrade, depending on which partitions that are placed on those devices. So let's start our documentation of Enterprise 6. So the features of Red Hat Enterprise version 6 major release. Now the features are similar to version 5, but a number of things have been changed, which we'll be looking at throughout our studies, including, for example, the switch from sysv init or system 5 init to upstart, as well as a number of other items such as where the default graphical interface is located on Control-Alt-F1, for example. So the current release, and this is a major release, is version 6. That goes without saying. And like before, it's still based on the 2.6x kernel. So that hasn't changed, still 2.6, but a number of new features are included. It supports graphical and text-based installations. We'll be performing both types of installations. The graphical installer provides more options. Let's just note that. So graphical installer is more feature-rich than text-based installer. But for simple installations, the text-based installer may be all that's necessary. It's quicker, requires less, and so on. But the default is to try to load the graphical installer. We've purposely restricted the memory on our server to 512, which will cause the graphical installation to fail, and as a consequence, revert to the text-based installer, and will allow us to proceed in that regard. But then we'll be able to perform a graphical installation either by upping the memory or by using VNC. Now, Red Hat Enterprise 6 can be downloaded, so it's downloadable via HTTP from redhat.com. You can obtain it on a trial basis, and you may also subscribe to Red Hat's services to be able to benefit from support, patches, fixes, security updates, and the like. Let's just note, available as trial and or subscription. So you may obtain Red Hat Enterprise version 6 on a trial basis for 30 days, which will give you support or access to support and patches and fixes for 30 days. And otherwise, you may subscribe for a number of years to obtain service support beyond the standard 30 days that's allotted. Additionally, this version is installable from a variety of sources, as we've grown to expect. For example, local media is obvious. CDs, DVDs, preferably DVDs, and we should just note that it is available as one DVD ISO image. which is just under about 3 gigabytes, which we have available on our Apache server to make it available for our installation. So it's in place, and we'll take a look at that momentarily. So local media may be used to install it. Well, let's just add to the mix that also USB, in the event that you place the contents of the ISO image onto a USB stick or USB drive, and your BIOS supports booting from USB, then you can boot from the USB stick or drive and install the operating system. Additionally, as you've come to expect, you may also install across the network, and this includes using HTTP as well as NFS as well as FTP. So these are ways in which you may install across the wire. We'll be looking at HTTP since setting up via Apache is rather simple, and since most environments have some form of web services enabled, whether Apache IIS or otherwise. You may also install using PXE. So PXE, which implies network installation. So it's basically a type of network installation, and that is where the entire setup process and installation is done across the wire, sans local media, which we'll be looking at as well. The PXE installation, it requires a little bit more of an investment up front to provision the environment, meaning setting up the DHCP server to serve the appropriate settings to the server or box that you'd like to place Enterprise Linux 6 on, and pointing it to the appropriate boot files on the network served by TFTP. But once that's in place, then you're able to perform, providing your BIOS supports a PXE-based boot, and installation across the wire sans local media. But it's not a big deal to also have local media. Let's just note some other features. KVM, or virtualization via KVM, is an option that's supported, which means you can host, like you can with commercial offerings like VMware, additional operating systems on your Red Hat Enterprise Linux 6 box. So it is a virtual server host when KVM is configured, and providing you have enough resources to spread across multiple operating systems. Let's just note that ext4 is now the default file system for new installations. So default FS for new installations. This means if you upgrade, as we're going to do, from an existing version to version 6, and the existing version contains ext3 file systems, or ext2 for example, then those file systems will be preserved. There is the option to upgrade the file system, but existing files will not take advantage of the new attributes that are available in ext4. So ext4 is the default file system for new installations. Let's just note that this actually means file system for new installations. And we should just also note that this also works, ext4, so also works with /boot, where the kernel and the grub loader files are stored, and this is due to grub support, whereas in prior versions it wasn't always guaranteed to work. It's now guaranteed to work. That means that the grub bootloader is compiled with support for ext4, so it is no longer relegated to ext3, ext2, and some other types of file systems. It supports ext4 as well, which means if your /boot partition is ext4, then grub can boot from that ext4 file system. And ext4 provides a number of features, including much more resolution on timestamps associated with files created within the file system, and wider bit length to support much more meaning surrounding the files, the inodes, and so on. A number of other features include, for example, disk encryption. You can encrypt all of your disks, including root. So including root And by root we mean / not / root, but / itself, the root file system. This adds, of course, an obvious layer of security that's often missing from many operating systems, including servers that are secure once up and running, but vulnerable if accessed in an unauthorized fashion, perhaps physically. Let's also note that Red Hat Enterprise 6 supports a number of platforms. And these are the traditional platforms that have been supported. These are the dominant platforms that are available today. They include x86 32-bit, as well as its 64-bit counterpart, x86_64. And this means you'll need to use different sources for different platforms. The x86 64 and x86 share the same sources, but IBM Power and System Z use other sources. So x86 64 covers AMD 64 and Intel 64, which should cover the majority of the boxes being placed into provision or being provisioned into service nowadays. In addition, IBM Power is supported and System Z for heavy lifting. So these are the platforms on which you may install Red Hat Enterprise Linux within your environment. Now we'll be working on the x86 platform, the ubiquitous x86 dominant platform, and the requirements are similar to version 5, but more memory and a little more storage as is expected. So system requirements, these are bare minimums. You should have at least a 1 gigahertz P4 processor or better. By today's standards, this is considered to be old, so preferably dual core or better. That's the real translation. And in addition, you should aim to have at least 1 gigabyte of RAM or better, preferably 4 GB or better. It will run, however, with less memory. In fact, our system has been reduced to 512 megs of memory, and it will run. The graphical installer will not run by default, but the system will install with 512 megs of memory. So in addition to the processor and memory requirements, the storage requirements include 3 gigabytes storage for minimum installation and 5 gigabytes storage for full installation, which obviously means you need more storage to provision for unallocated space for the future, perhaps in use in LVM volumes as an example. Another note, another feature is that there is compatibility support built in for older programs. So compatibility support for older programs. This is to ensure that older programs or programs that rely upon older libraries continue to function, since Red Hat guarantees cross-version compatibility with programs that have been basically certified by Red Hat. So, for example, you will notice when you use RPM query list a number of compatible RPMs, or RPMs that are prefixed with the string compat. So when you see compat RPMs, these are libraries. So let's just note, these are libraries to ensure the operation of older programs. So a number of compatibility RPMs are included. So it's a feature because it ensures, let's just note, this ensures that certified applications continue to run without having to recompile or change the programs. So it provides a clear upgrade path from a given version to another version. And we just have a few points regarding the Anaconda installation system. And that is Anaconda auto formats the disk that you provide it with the following layout. Creates a boot partition, a root partition, as well as /home, but the /home is created if you have greater than or equal to 50 gigabytes of storage. Otherwise, the installer will create boot and root, and it will also create a swap partition, as is required by the operating system to run. So by default, Anaconda in this version of Red Hat Enterprise Linux will provision the following file systems. And again, you'll also see a 50 or a home partition if you have 50 gigabytes or more, which should cover all modern systems for the past many years. So you should end up with a minimum of boot, root, home, and swap. Now, our system has 3 36 gigabyte hard drives. We like to use older systems with installations because it proves that if the operating system is able to be installed in an older system, then it should be able to be installed on a newer system with respect to storage and memory at least. The processors are pretty beefy. They're Xeons 2.4 gigahertz and multiple Xeons with hyperthreading support. So the processor support is hefty, but the storage and RAM support is meager. And that drives home the point that you're still able to install the operating system with meager storage and RAM resources. So in our case, a /home directory will not be created automatically. Now for the upgrade, whatever partitions are in place will be created. That will not change. Let's take a look, for example. If we df-h, we'll see what's available. So we see that the 36 gigabyte hard drive is partitioned into one partition /. And that partition will be replicated when we upgrade to version 6. But when we create a new installation and subsequent installations, you'll see the new layout of boot, root, and so on. Now with respect to file system type, mount tells us the different types of file systems that are mounted. And if we grep the contents of etc/fs tab or just simply cat etc/fs tab, we'll see more specifically the file system types with defaults indicating that it's usually ext3 with respect to Red Hat Enterprise version 5. Let's sun. We'll rerun mount and shows us the same information, but also note ext3, just like with the non-privileged user. But as this user, we can now run fdisk to take a look at the individual disks. So we know, for example, that SDA is the hard drive that's in use, and SDA1 is the root partition, which means there's possibly an SDA2 which is being used for swap, and the free command will confirm whether or not swap has been enabled. So for example, here's what appears to be a gigabyte of swap. So there is a partition for swap, and our path is not updated to include it whenever we run it in this case. And let's go ahead and do a dump. And that's the S option, so let's clear screen, do that again. And there we see that SDB1 is where the swap partition is located. So it's not actually on SDA, but on SDB, which is the second of 3 hard drives. Now let's sbin fdisk, and we'll list dev SDA. This will enumerate the partitions that are configured. Only one partition is configured, and that's for the root file system, and it's occupying basically the bulk of the disk. So, or if not, all of the disk, 1 through 4427, all of the cylinders. Whereas SDB, the second hard drive, is configured with a number of partitions, including SDB1, which is a swap partition, type 82, and extended to house additional partitions, and SDB5, which is an LVM partition, which is not mounted currently, as per the dump from DF. So with that said, we know what the storage landscape will look like once the system has been reinstalled and or upgraded. And if you'd like to get a sense for the amount or the number of processors and the speeds with which they operate, if we cat proc CPU info, this will enumerate the CPUs that are installed, and notice they're 2.4 gigahertz, index at 0 and 1, so, and it runs all the way through, let's just check, 3, so there are 4 processors configured. And this is with hyperthreading, so 2 physical, which is equivalent to your core processing, that's available. So 2 physical, 4 logical processors are available. So Anaconda will resort to this sort of storage layout and include home if 50 gigs or greater are available, which means if we were to amalgamate 2 of the 36 gigabyte drives into, let's say, a RAID 0 stripe, then that would appear to the installer Anaconda to be a block that's greater than or equal to 50 gigabytes, thus resulting in the creation of a /home mount point. Let's just make another note about Anaconda with respect to network configuration. And that is that Anaconda and the running system, meaning once the operating system's up and running, now both use the same facility for network configuration. And that's Network Manager, which you will find across Linux distributions, including Debian, Red Hat, etc., SUSE, etc. So Network Manager is used to auto-configure networking as opposed to a separate facility, which means by default Network Manager will attempt to use DHCP to configure your connected interface or interfaces. So uses DHCP by default and requires minimum intervention, which is the key. So you're not constantly tinkering with or tweaking config files, the if config files beneath etc system network interfaces or system config network interfaces. So as a consequence, the network management is handled for you with as little intervention as possible. However, one of the long-standing features of the Linux kernel is the ability to absolutely control every variable imaginable. So let's just note that Anaconda, which happens to be the installer used by Red Hat Linux, still supports absolute control over variables, which means, for example, network settings may be specified during its installation as opposed to relying upon Network Manager using DHCP, which you will see. So for example, this server has an IP address of, if we run ifconfig, it'll tell us, but it's going to terminate in .20. On the IP version 4 network, it's 192.168.75.20. So supposing we wanted to reuse this address constantly as opposed to relying upon the network manager to use DHCP to obtain an address from our DHCP server, then we could specify that the IP address to use during installation is just this address, 192.168.75.20. And we can also control the other settings such as the net mask, the broadcast address, the gateway, which nets that RN will reveal as 192.168.75.1, the DNS servers, which are configured in etcresolve.conf. All of these values may be specified during installation to influence how your system interacts with the network. So a number of features very similar to Red Hat Enterprise 5, but of course with extensions and improvements, enhancements, and the like. So we're now on to version 6. Now what we should do is finish prepping the environment, or prep the environment, confirm the environment with which we will be connecting across the wire using HTTP to provide the installation. So now let's go ahead and save this document and just confirm that the Apache configuration is intact. So we're going to save this as Linux CBT EL6 edition notes.txt, which of course is in your docs directory and can be referenced throughout our coverage of the product. Now, to confirm the environment, we'll connect to our Debian box, which is located at 101. Before doing so, let's just note what we're doing here. So, prep installation, which happens to be an HTTP server. And it's quite simple using the ISO image. So features include, of course, easy access to ISO image contents. That's why we want to do this. Now there is an ISO image for version 6 in our server, so tasks include mount ISO image in web accessible directory. And this is going to be on the server 192.168.75.101, and we'll place it beneath our web accessible location Linux CBT. So that'll give us a URL that's usable during installation, which we'll store in our notes. And of course, since we're installing on this server, our notes will not be available during the upgrade, but nonetheless will be available eventually. So let's SSH to 75.101. We'll accept the public key as the first time, and we'll navigate to Linux CBT where our items are stored. We've already created a directory, labeling it EL6, and if we LSL, there's a miss directory, and in it is the version 6 DVD i386 image. LSL TRH 2.8 gigs, and this file will be mounted into a distinct directory. Now we can create the directory beneath miss and then simply reference the full path. IP address / Linux CBT EL6 miss. Apache is already configured to serve the / Linux CBT directory using auto indexing, so it's accessible from the web. So for example, let's go to the browser and show you what we mean, or we could use LFTP, either or. And we'll start a new session. So from the perspective of Anaconda, it's going to walk the remote server as follows. So 101/Linux CBT/EL6. And this is what it'll see. But we'll then feed it miss and then a new directory where we'll mount this ISO image. So that's the intent, which means we should make a directory. Let's call it rel6. And then we'll mount using mount type ISO 9660 because that's the type that it is for optical media, and it's a loop device. And we'll mount rel6 DVD ISO for i386 into the rel6 directory. And regarding the sources, there is, since this is labeled i386, we can tell momentarily, there is possibly a separate ISO image for the x86 64. Let's take a look at the server directory. That'll tell us, and then the packages that are there. And let's see what that reads. It's a symlink. This is going to enumerate all the packages, and it appears that this is strictly i386. So there should be a different download for x86 64 as opposed to them sharing sources. So rel6 is now mounted. And that means if we refresh in the background in the browser, using Control-R for example, we should see rel6. This is the path that we'd like to feed to Anaconda. So let's place it in our notes, and this is a path that we'll memorize during installation. So URL is equivalent to the following. This will allow it to find the images subdirectory. And let's just take a quick look. It'll find the install.image. There's also a PXE boot directory which contains the PXE files to assist you in booting across the wire. One other note, and that is downloadable from the Red Hat site is the boot image, an image that you may burn to a CD-ROM for booting, which we've already done. So let's just note boot ISO image may be downloaded from redhat.com or created from DVD ISO image. And if you take a look at the DVD ISO image, let's change into its mount point. You'll see a number of directories, LSL images, and the various images are there for us to make our ISO images. There's also ISO Linux, which is another boot environment. And if you do a find name *ISO*, this will search the tree in search of anything ISO related. ISO Linux, ISO packages, so on and so forth. But it's the image file that we can burn to boot the client or the server in this case. But you may also download the image from redhat.com. And you may also set up the PXE boot environment to boot as well. So now our server is set up. Next, what's left for us to do is to boot with that CD and provide some options on the boot prompt with respect to the Linux repository. So let's just note that our next task is to reboot server and supply the following boot string. And it's not a hard rule that this must be the string, but these are some sensible options. So at the boot prompt, we're going to press tab to edit the option provided by the boot CD, which will allow us to edit that grub entry that's supplied on the CD. And we're going to specify Linux followed by a number of options. We're going to indicate a repository, setting it equal to the path we've just mentioned. So let's copy this path and paste it. And this will be the repository. The repository can be FTP, NFS, or HTTP. Since we're using HTTP, that's what we'll reference. We can optionally set the resolution, but the graphics installation is going to fail. But I'll specify it anyway. Setting a resolution equal to 800 by 600. We may also determine the IP address that's used by setting IP equal to the following address, which it currently uses. And let's also set the net mask equal to 24 bits and the gateway equal to 75.1. And we may also set the DNS server, and if you've got multiple servers, then specify them using a comma delimiter. We'll just specify 101, which is our Debian box, as the DNS server, although DNS is not required during installation, but it's just a typical tendency to want to have DNS in place in the event that we did need to perform a lookup from one of the available consoles. So when we reboot the server, we'll supply the following boot string by pressing tab. So let's just note first, press tab to edit boot option, and then supply the string. We'll be appending the string, so perhaps we'll just note that this is to be appended to the existing boot string because there are options already specified. And it'll be read that the repository will be located via HTTP. The resolution is to be Super VGA. The IP, netmask, gateway, and DNS to be set as follows. There are a number of options that are supported that the Linux kernel will read. They're covered in the documentation of Red Hat Enterprise Linux, which you can get from their website. But these are sensible for our installation, at least for our upgrade, for our initial installation. So next, let's reboot the box. Let's close this out from now and perform, or at least attempt to perform, an upgrade of this system.